Hello and welcome to the last example, example 3, where we're going to find the second solution, the y sub 2, of our non-homogeneous equation. And we're given a solution that is associated with the homogeneous equation. So to find the second solution of the homogeneous equation and a particular solution of the given non-homogeneous equation. So all we're going to do is we're going to use a reduction of order where we're going to say, well, y sub 2 is equal to y sub 2 over y sub 1 is equal to u of x, where we're going to be able to say, well, then y is equal to u of x times y sub 1. All right, so we're just going to use that part. So we're going to go ahead and substitute in for y sub 1, which is e to the x. We substitute in, and then we're going to go ahead and find the first derivative and the second derivative. So there's the first and second derivative. Now again, here's just the second derivative simplified. So we found the first or second derivative, and we're going to substitute in. So we substitute in, and there's y double prime minus 4y prime plus 3y equals x. We substitute in, we're going to simplify the left-hand side. When we simplify the left-hand side, we notice, okay, u double prime e to the x is going to stay, and then our 2e to the x u prime, and we have a minus 4u prime e to the x. They're going to turn into minus 2e to the x u prime, and then e to the x u minus 4e to the x u plus 3e to the x u. They're going to all cancel out, and so we're left with e to the x u double prime minus 2x e to the minus 2 e to the x u prime equals x. Now, from here, what we're going to do is we're going to go ahead and let's substitute in w so that we can turn this into a first-order linear differential equation. So we do so, and then we're going to divide both sides by e to the x so we could put it in the standard form. So we're dividing everything by e to the x. When we do so, we're left with this first-order linear differential equation, so we're going to find an integrating factor. Integrating factor, we're going to use the p-value. So e to negative integral 2 dx is just going to equal e to negative 2x. We're going to multiply both sides by that and take the integral of the right-hand side. So when we multiply, we're just going to get the integral of x e to the negative 3x dx. After that, we're going to go ahead and take the actual integral of that. We're going to do integration. Over here to the right, I did the integration where I just did the tabular method. I think that's what y'all call it, or the tic-tac-toe method. And we're going to get, on the left-hand side, we're going to get e to the negative 2x w equals e equals negative 1/3 x e negative. So we just took the derivative of the right-hand side. Sorry, we integrated. So after we integrate it, we get that on the right, and then we're going to get rid of this e to the negative 2x. So we multiply everything by e to the negative 2x. Or divide everything by e to the negative 2x. And we get w by itself. Now, we don't want w, we want really y, and so we know that w is equal to u prime. And so we're just going to set that equal to u prime. So on the right-hand side, we're left with u prime. On the left-hand side, we need to integrate all of that. So we integrate everything, and we're going to be left with u. Now, we know u is equal to y. Y is equal to u times y sub 1. So we're going to take everything that we found in u, and we're going to multiply it by y sub 1. And our y sub 1 was e to the x. So we're going to multiply everything by e to the x. When we do that, we're going to get y equals 1/3 x plus 4 over 9 plus 1/2 e c sub 1 e to the 3x plus c sub 2 e to the x, which gives us our particular solution and our y sub 2. Our y sub 2 is going to be that with the constant. So again, here you see, oh hey, that was our y sub 1. Y sub 2 is going to have the other constant that's shared, so 1/2 c sub 1 e to the 3x. Again, it's c 1/2 times c sub 1 is still going to be a constant, so it's just e to the 3x. And then this right here, you see, has no constant, so that's our particular solution. And so our particular is y of p, and our second solution to the homogeneous part is y sub 2 e is equal to e to the